So let's say I tell you to take the average rate of change of this parabola between point A and point B. Now what would you do? Basically, you would draw a line from here to point B, and you would say, I want to take the slope of this line. Right? So if you take the slope, you find the rate of change for every x value, or for every change in x, you find the change in y. Okay, let's say instead of point A and point B over here, what if I decrease the distance between point A and point B, and we make them closer and closer and closer and closer, such that they're so close that they become one point in the center, right here. What about then? Well, that's what derivatives are. So when you're talking about the average rate of change, you're talking about delta. This indicates the change between 2 points. So you're basically drawing a secant line in the graph, and these points are two distant points that are a distance away, so that we can calculate the slope and find the change in y over the change in x, where this triangle symbol, if you didn't know, means delta. Okay, so like we talked about, we are trying to find the slope of the tangent line. So to do that, we need to understand that technically, you cannot take the slope of one point, and we don't know any other points on the tangent line. So to take the slope of the tangent line, we have to rely on that one point, but we can use limits from the limit definition of a derivative to understand how to do this and prove how a derivative works. So let me remind you again. Basically, if you have point A and point B, for a derivative to work, the distance between these 2 points will decrease so that there's basically no distance. So this distance should be approximately 0 in the x direction. Now, the limit definition of derivative is basically this. F of x, which is the derivative of the function of f of x, equals limit as h approaches 0, we'll come back to that in a minute, of f of x plus h minus f of x over h. Now, here, h is the distance or the difference in the new x. So basically, you are looking at the slope equation, but you're modifying it. The change in y over the change in x. It's basically this, but with a different context. So, h here represents the change in x. So basically, f of x here is y. You know, f of x is y1, and f of x plus h is y2. Now, h represents the change in x. So if you add the change in x to x1, let's say, you get the second x value, right? So let's say x2 minus x1, which equals delta x. H is that delta x. So you're basically calculating y2, which is x1 plus the delta x, which is x2, right? So basically f of x2, which is y2 minus y1 over delta x, which is h. Got it? Now, let's rewrite that over here. Equals limit as h approaches 0 of f of x1 plus h. Now again, we're not going to write the x1 because that's not needed, but I just put that for contextual purposes. So Now, what does the 0 mean? We talked about how the distance between point A and point B in the x direction must be 0, right? So that's what we're trying to do. We're trying to get the limit as h approaches 0. So we cannot put a 0 in for x directly because that would be undefined here and here. So that's why we're taking the limit, because even though at that point it might be undefined, as we get closer and closer to 0, we might actually get a number or some kind of an equation in this scenario, which we'll see. So basically what we can do is use this equation to find the slope of the tangent line at point C, where point A and point B have a distance of 0 in between. So let's talk about what the derivative of an entire graph means. In this case, the derivative of f of x, which is this parabola, a quadratic function, would be a linear function, f prime of x. Now, this is not necessarily, you could think of it as the slope of the parabola, but I like to think of it as, for every single point on this parabola, this line will have the slope of the tangent lines for every single point on that parabola. So at point C, whatever my x value is for that point, if I pick the same x value on this line, I will get the slope for the tangent line of point C. And this works for every single graph, if it's continuous and it has an actual derivative. Now this formula right here gives us the graph. It gives us this derivative graph, or the graph's derivative. So it will give us the equation for this line. Using that line, we find the slope of the tangent line by putting the same x value as point C, and then we find the slope of the tangent line, which shouldn't be that difficult. So let's demonstrate this. So let's say our f of x here is x squared plus 3, right? So I'm going to rewrite this equation like this. So limit as f prime of x, so f prime of x equals limit as h approaches 0 of f of x plus h, which could be written as x plus h squared plus 3. So all I'm doing is replacing that x squared with x plus h. I'm just putting the x plus h in the x squared. And this has to be in parentheses, remember, minus x squared plus 3. Okay, now this will be h. So let's combine like values. So, or terms. So these 3's will cancel out because 3 minus 3 is 0. So all I'll have here is f prime of x equals limit as h approaches 0 of x plus h squared minus x squared over h. Alright, now we have to expand this, because we need to find a way to get rid of that h in the bottom. So f prime of x equals limit as h approaches 0, x plus h squared, that should be x squared plus 2xh, and then that would be plus h squared minus x squared. Okay, so if you look at this, how convenient. These x squares here will cancel, or they'll subtract out, and we'll have no x only no x only terms on here. So every single term here has an h. So we can divide out the h. So what we'll have is f prime of x equals limit as h approaches 0 of 2x plus h over 1. Now we don't have the problem of putting a 0 into the h and having a 0 over 0 anymore. What we'll have is a definite answer. So let's plug in the 0, and what we have here is actually f prime of x equals 2x. That is the derivative of x squared plus 3, 2x. Great. Okay, so what now? We have the equation for the derivative of our function. Okay, so let's say we're trying to take the derivative at precisely x equals c. I want to find the slope of my tangent line, or the instantaneous rate of change. Well, I could just plug in c. F prime of c equals 2c. Now, whatever c is, any x value, let's say c equals 8, you get a definite slope. F prime of c equals 16. And the beauty of this is, this here can work for any single x value because we found the function already. So if they ask us more than one point, all we have to do is plug in that number in here and we'll have the answer without doing any more derivative or limit work. Now, basically, this is another way you can look at it, which is the f prime of c method, where you're directly finding the instantaneous rate of change at that one point without finding the equation for derivative. So basically what changed here is this is more of your slope format. So you have the change in x over here, and you have the change in y over here. And again, it has the same problem of when x is c minus c is 0, and this would also equate to 0, so it's 0 over 0. So you have to do more limit work. But this might be simpler, and also sometimes it's faster, but not that much faster, because this equation right here gives you, one additional step, which is plugging the number into the equation. But I think this is a better idea, because that way, if you're given multiple numbers to find, you don't have to do the limit over and over again like you would do for this one. But rather, if you find the derivative in one try, then you can find the slope of the tangent line or the instantaneous rate of change for each point that you need to find. So unless your teacher specifically asks you to do this one over here, I suggest doing the one I showed you before. Okay, now let's say using this, I'm trying to find f prime of 2. So what I'm going to do is replace c with 2 for every instance. So x approaches 2 of f of x. This will stay the same. Minus every time you see a c, we'll put a 2. X minus 2. So we're going to repeat this again, but we're going to substitute everything we know. So limit as x approaches 2. F of x can be written as x squared plus 3 minus f of 2 is 7 over x minus 2. Now we cannot put in the x yet because that's going to be 0 over 0. So what I'm going to do is simplify this. And what this will be is f prime of 2 equals limit as x approaches 2 of x squared minus 4 over x minus 2. And if you look at this, anytime you do something like this and the derivative exists, this will always simplify to something like this. So you can always factor out, like I said, so x plus 2 times x minus 2 is equal to x squared minus 4. So x minus 2 and x minus 2 cancel out. So In other words, we'll have f prime of 2 equals limit as x approaches 2 of x minus 2. So these two divide out. And then when you plug in 2, since we have no denominator, 2 plus 2 is 4. So that's the instantaneous rate of change at f prime or f of 2, or f prime of 2 equals 4.